Add or subtract 10x over x minus 1 minus 27 over x plus 1 plus 33 over x squared minus 1. Well, the first thing we need to do is find the least common denominator, which is x minus 1, x plus 1. And I'll go ahead and write each of the fractions as x minus 1, x plus 1 with the denominator. Now I'll look back to see what they're missing. Well, the first one's missing x plus 1. So it becomes 10x squared plus 10x. The second one's missing an x minus 1. So it becomes 27x minus 27. Notice I left the subtraction symbol there. The third one isn't missing anything, so it stays the same. Next, I just need to add all the numerators and keep the denominators the same. So adding my like terms gives me 10x squared minus 17x plus 60 all over x minus 1, x plus 1. And whether the numerator factors or not, it doesn't factor to be x minus 1 or x plus 1, so we don't need to factor it. Next, I want to compare this to when we solve equations. So we have 10x over x minus 1 minus 27 over x plus 1, and now there's an equal sign in the problem, so equals 33 over x squared minus 1. The first thing, again, is to find your lowest common denominator, which is still x plus 1, x minus 1. But this time, notice everybody's getting the same thing, not what they're missing. Everybody's getting the x plus 1, x minus 1 all over 1. This allows me to cancel my fractions. So the first term became 10x times x plus 1. The second fraction became minus 27 times x minus 1. And then on the other side of the equal sign, we just have 33. Now I need to simplify. I get 10x squared plus 10x minus 27x plus 27 equals 33. Since this is a polynomial, or a quadratic in particular, we need to move everybody to one side and get 0 on the other. This gives me 10x squared minus 17x minus 6 equals 0. So factoring this, it becomes 10x plus 3 and x minus 2. Setting each of those equal to 0, I get x is negative 3/10 and x is 2. However, I might be dividing by 0, so I have to check the domain values. So you look at the original problem and you see that x is not allowed to be 1 or negative 1. And so both of my values are okay. Next, I want to compare this to simplifying a complex fraction. So notice I'm using the same three fractions. So this time we have 10x over x minus 1 minus 27 over x plus 1, and then the whole thing is over 33 divided by x squared minus 1. And I'm going to use the method of wiping out the extra fractions, which is method 2. So just like before in the other two problems, you have to find your lowest common denominator, which is still x plus 1, x minus 1. And since my goal is not to add the fractions, but to wipe them out, then I'll do like I did when I solved the equations. I'll go ahead and give everybody x plus 1, x minus 1 over 1. So you can see that being written out. Again, this is fair because even though there's no equal sign, I'm giving the top set of fractions the same thing that I'm giving the bottom fraction. So I'm still multiplying by a value of 1. So this leaves me with 10x times the quantity x plus 1 minus 27 times the quantity x minus 1 in the numerator, and then in the denominator we just have 33. So next I have to simplify the numerator. We have 10x squared plus 10x minus 27x plus 27, and then it's all over 33. Finally, there's one more step to simplify. Adding my like terms, I just get 10x squared minus 17x plus 27 over 33. The only way I would want to factor the numerator is if it had a 3 or an 11 in it as a greatest common factor, and it doesn't. So whether it factors or not, I don't need to factor it.